Welcome back to this episode of Miss Max Academy. Today we're going to talk about line of best fit and residuals. A line of best fit, or a trend line, is a straight line that best represents the data on a scatter plot. So here you clearly see we have a scatter plot. We have a bunch of information that we collected, and this red line would represent the line of best fit. This line may pass through some of the points, none of the points, or all of the points. In this case, you can clearly see it passes through some of our points, but clearly not all of them. And the line of best fit lies as close as possible to all the data points. That's what makes it the line of best fit. The equation of the line of best fit. This equation is kind of funky looking. It's read as y hat equals b plus ax. Hopefully this kind of looks familiar to you. In algebra, you saw this as y equals mx plus b. So some things look a little different and some things look the same. We still have the y and we still have the b, but instead of the mx, we have ax. So a is now the coefficient of x, so a is the slope of the line. Again, we read this as y hat, or the predicted value of y. So the predicted value of y can be given by b plus ax, where a, the coefficient of x, is the slope of the line, b is the y-intercept of the line, x is the explanatory or the predictor variable, y is the variable of interest or the response variable, and just a reminder, x always predicts y. Calculating the residual. We actually had this slide in a previous presentation. I just wanted to review how you calculate a residual. To find the residual, it's the observed y value, subtract the predicted y value. A negative residual means the observed value is less than the predicted value. A positive residual means the observed value is more than the predicted value. Let's take a look at an example problem. This actually came from Khan Academy. Vera rents bicycles to tourists. She recorded the height in centimeters of each customer and the frame size in centimeter of the bicycle that the customer rented. After plotting her results, Vera noticed that the relationship between the two variables was fairly linear, so she used the data to calculate the following least squares regression equation for predicting bicycle frame size from the height of the customer. So again, x always predicts y. So if we're predicting bicycle frame size, then bicycle frame size is our y variable and height would be our x variable. Okay, and again, this is what that equation would look like. The predicted value of y is equal to 1/3 plus 1/3 times height. The question is, what is the residual of a customer with a height of 155 centimeters and a bike size of 51 centimeters? I just restated the question at the top of this slide. I also restated the equation, but notice I rewrote my equation using the units and clarification of the variable, because that's what's interesting to us in statistics is we're descriptive. We want to describe what the variables stand for. So the predicted value in y is the predicted bicycle size. So the predicted bicycle size can be given by the equation 1/3 plus 1/3 times a person's height. So what are we going to do? We're going to plug it in, and find the predicted bicycle size of a person whose height is 155 centimeters. We have the actual size. The actual size is 51 centimeters, but we want the predicted bicycle size. So let's take a look. And here we go. Here's our original equation. Predicted bicycle size equals 1/3 plus 1/3 times the height. And wherever I saw height, I plugged in the person's height of 155 centimeters. When I multiply 1/3 times 155, it just becomes 155 over 3. If I have 1 over 3 and I add to that 155 over 3, that gives me 156 over 3, or 52. Well, what is this number? This is the predicted value of a bicycle frame size for a person who is 155 centimeters tall. So now we have to answer the question. What is the residual of a customer with the height of 155 centimeters and a bike frame size of 51 centimeters? Well, residual is observed Y value minus predicted Y value. The observed Y value is given right here in the prompt, 51. Subtract the 52, which was the predicted Y value. We got that in the last slide. And 51 take away 52 gives us a residual of -1. This is the correct answer for this prompt. The question is, what is the residual of a customer with a height of 155 centimeters and a bike size of 51 centimeters? And the answer is the residual is -1. Well, what does that mean? It just means that this customer's bike size was 1 centimeter smaller than the model predicted. Tune in again for the next episode of Miss Max Academy.